The Teslas Cybertruck is there. But instead of a general summary of the vehicle, I want to discuss the wider impact of the Cybertruck on the car world. Because Tesla does it again. Again, they fulfill car engineers' dreams. Things that seemed impossible so far and things that you, as a car engineer at a traditional car company, simply cannot achieve. A couple of examples. In 2015, at my previous job in the technical development of Audi in Germany, I had the idea to combine the air tank for the air suspension, the aluminium crash bar at the front, and air guides for cooling flow to the radiator in one part. That wasn't possible because no one could work out who would own this part. Is the suspension department responsible because of the air suspension reservoir, or the aerodynamics department, or the crash department? And if two of these departments would lose their part in the car, they lose their power in the car project. So traditional car manufacturers are not interested in combining multiple functions in one part. 8 years later, the Tesla Model S Plaid came out with a so-called super beam, a structural beam which is the air suspension tank at the same time. When we designed cooling systems for electric cars, we developed new valves with 3 and 4 connectors, which was the maximum we could do with our suppliers. Tesla presented the octo valve, so a valve with 8 connectors a couple of years later. We had problems packaging the standard onboard chargers in our vehicle, costing the customer lots of storage space. Developing our own charger wasn't an option, we had to go with the supplier box. When Tesla ran into the same issue at the Model X, they just created their own large flat onboard charger, which could be efficiently packaged. And we could go on with this list for a lot longer. When we are looking at the Cybertruck, the previous Tesla innovations are all included. But let's talk about the big new things that will disrupt the car industry. The body structure. And we don't want to talk about the stainless steel body panels, which is a nice story that they are tough and bulletproof, but really interesting is what happens underneath. First of all, there are large castings at front and rear. Possibly a single casting at the front and 5 casted pieces at the back, 1 large one and 4 smaller ones. We have a center section which is possibly built in aluminium, but with a huge hole in the middle. That is the place for the battery, which becomes a structural member in the Cybertruck. So the center part, which is the connection between front and rear, can only get its high stiffness by adding the battery pack. And that is new as car manufacturers usually put their battery in a box, which they then fix in a dedicated box in the body. And a box in a box is never a good idea, in terms of weight, materials and vertical height. Ever wondered why no one else can build a low electric car with a flat battery and without holes? So that brings Tesla a huge step closer to the future vision of building a car with 3 key components: front casting, battery, rear casting. The amount of time and work that you can save with this method is impressive. Also, you can build the car in a different way if we think about crash behavior, fasteners and so on. Tesla already has a number of years of experience here, others don't. The next revolutionary step here is the voltage. Firstly, high voltage is at 800 volt, which is the new industry standard. If you want to transmit the same power, but you have double the voltage, you only need half the current. And current is what makes cables fat. So changing to 800 volt can save a lot of money, long term. It's not new because many other electric cars work with 800 volt as well. But there are also not as many suppliers for parts yet, but it's a step in the right direction. Even more significant is the step from a 12 volt low voltage system to 48 volt. Many will say now that it's nothing new because other manufacturers are doing this for years. But they're only doing this for certain high power applications and the rest of the car stays 12 volt. Changing the whole car to 48 volt is a huge step. Cables can become a lot thinner, you need much less copper, so it's less material and less weight, and more power for the individual components and functions. And I am telling you that as a driver of 6 volt cars. So why does no one else do this? Because all suppliers of all sorts of components in the car work with 12 volt. So if you are depending on suppliers, it's an impossible task. But because manufacturers persuaded their suppliers to not work with Tesla in the past, Tesla built most parts themselves, and today they own the supply chain. Many components that usually come from suppliers are done by Tesla themselves. And that's another factor for great engineering, bringing knowledge back in-house. Having people in the next office who you can discuss with about technical specifications instead of writing hundreds of emails and going to endless meetings to get the next budget for your supplier. And in the end, no one at the manufacturer has a clue how their own car works. And also, if you own the supply chain and you do everything yourself, you cannot be copied. So that's another dream of car engineers, doing the actual engineering all in-house and creating something that seemed impossible. The Tesla Cybertruck might be a very unusual car, but it pushed multiple topics ahead. Again. Let me know how you like the Tesla Cybertruck in the comments below, and see you at the next video.